Welcome to Access to Analytics, the show where we discuss everything data and access to data.
Hey, welcome everybody to another episode of Access to Analytics. This episode is a very special one because today's guest is a big voice in the world of data, really shaping the world of data and how we use data. He's one of the biggest thought leaders when it comes to data contracts. And it's crazy what he has done with his community, because if you look at his community data quality camp, it has reached more than 6,000 members in a couple of months, which is a crazy feat. I guess by now you know that today's guest is Chad Sanderson. Hey, Chad, how are you doing?
Hey, I'm doing great. How are you?
Doing very well. Chad, did I miss anything? Can you introduce yourself?
Sure. Well, I think you covered most of the important things, but I am the owner of Data Quality Camp, and to Bart's point, we are at over 6,000 members. These are all practitioners in the data quality space who are operating at scale and thinking about how to apply quality and governance and security to, businesses who actually really care about data. And that's been great. And then prior to that, I was the head of data platform at a company in Seattle, Washington called Convoy, which is a startup. And I managed a team of about 20 people. Some were data engineers, some were software engineers, and we focused on maintaining pipelines and also building platforms for data quality and data science. And then altogether, I've been in data around 10 or 11 years or so.
That's probably also where at Convoy and in previous jobs where you've seen like the importance of data quality, right?
Yeah, that's exactly right. Convoy was a really interesting place to work for a few reasons. One was data was really at the heart of the business. So Convoy was a two-sided marketplace, kind of like Airbnb, except we focused on freight. So you had a buyer, which was our shipper, and they were trying to move some freight from one end of the United States to the other end, or one facility to another facility. And then on the other side of the marketplace, we had truck drivers or companies that owned a lot of trucks, and they participated in an auction. And then Convoy, the business, basically sat in the middle, and we would facilitate going out and bidding on shipments that the shippers wanted to have moved around, and then we would make those shipments available in our marketplace through our auction, and we would try to optimize for things like optimal routes and batching loads together, so the truck drivers would take sort of get the greatest amount of value with the least amount of time spent on the road. And all of that optimization process was handled through machine learning models. And of course, like those models were, driven by the quality of data that we had. The less good the data was, the worse the predictive capacity of the model, and the less money Convoy would make. So it was one of the first businesses I've really worked at where there was a direct impact of data quality on money, and the entire business was very aware of that relationship.
Like years back when people spoke about data quality, it was in some kind of management report where there would be questions about the numbers to go back, and the next day you would have a new report. But in your case, you're working at Convoy, you were working with very complex ML models. Route optimization is one of the hardest things to do. So you got a real-time model that has to give real-time results and has a real impact on revenue, right? So really feeling data quality issues, seeing the impact on the bottom line. And is it there that you came across the idea of data contracts? Like, was there some kind of big data quality issue that made you realize, like, hey, we got to solve this?
Convoy is not a old company, but it's not a young company either. When I joined, it had been around for about 5 years already. And so, or maybe it was 4 years, I think. And so they had spent a lot of time working on the product for those first 3-4 years. So we had a really good front end UI. We had some strong microservice oriented architecture that had been set up. We had a great sales team, right? A lot of the foundations that you need to start to basically say that you have achieved product market fit was there. What wasn't there was the data quality, and it was starting to become pretty noticeable in the performance of some of our models, meaning that we would have regular outages either for some of our machine learning systems or for just like some of the tables that fed into very high value reports that the CEO looked at and things like that. And this was a pretty, it got so bad that we actually had to have a sort of a larger, almost emergency-like meeting where we talked about all the outages with the CEO and the CTO of the company. If the models are failing on such a regular basis, then A, that's a really bad experience for our customers. It has a direct impact on them. And B, it has an impact on our bottom line. We could lose hundreds of thousands of dollars in a single day. And if you had more silent failures, so let's say changes to business logic from a database and some engineer didn't even realize they were impacting a model in some negative way, then it might actually take months to uncover that, and that error could cost millions of dollars. And we had a few of those as well. And it essentially reached a point where we just had so little visibility into when these failures were happening, who caused them, what was the actual change that caused them, that there started to emerge a lot of conflict happening between the data consumer, like the data scientists and analysts, and the data engineers who are responsible for the infrastructure. The infrastructure team was getting blamed a lot for these outages and these failures, when really there was not that much that the data engineering team, that my team could do about it, because then we were just maintaining the infrastructure and the pipelines, and we didn't have any control over what a producer decided to change.
Like there were some data quality issues. You guys managed the infrastructure, and you get to blame, and it must have been extremely stressful. That's something that's really interesting. You said like data quality led to some model failures. This is probably something that will become even more important, right? As we're going to the large language models, AI is becoming more and more important. We'll probably see more and more of these model failures because of the data quality issue. How can a data quality issue lead to a model failure? What does that look like?
People can fail, quote unquote, in a variety of ways. You can think about it as just the whole purpose of a model is to have predictive capacity. And so if the model is not predicting accurately, then not only may it not be helpful, but it could actually be anti-helpful, right? Like you could actually create a better user experience by not having a model at all if the predictions are wildly off from what that customer wants, or what the business needs. And so a failure could happen through, let's say, a change in business logic. You can imagine if there's some column in a database upstream that's called shipment distance in miles, right? Because we're in the US. And this is used by some model to predict how much money any particular auction should be, what should the starting price of any auction should be. And then if some engineer decides, you know what, we want to move to a more international standard, and we want to stop being special snowflakes. So let's change this shipment distance in miles column to be kilometers. And there's a good reason for doing that, right? They're following an international standard. Maybe there's something they want to start surfacing kilometers through the application because maybe more truck drivers are used to it. I don't know. There's like some reason they want to do it. But if the model hasn't been prepared for that, then overnight it would look like all of the shipment distances are cut in half, and then it would appropriately start to underprice those shipments by 50%, right? And that would have a really, really bad impact for Convoy, who essentially makes money on taking the difference from what they, what price we were paid by a shipment to take freight, minus the cost that we're paying out of the truck driver to actually move the freight. And that would lead to negative margin shipments for us, which means that we could lose money on some really important loads. So that's sort of one type of failure. It's just business logic. The other type of failure is just the pipeline breaks, right? So if there's something unexpected that comes through that pipeline that the model doesn't expect to be there, or some intermediary table doesn't expect to be there. So for instance, null values. Right? If a model is being trained on, a row level entity, and that entity coming from a database has a null value, that basically has to be thrown out, or the model is not going to know what to do with it. And so you need to have some processes in place to catch these things. And generally speaking, it's really hard to build test infrastructure that's so comprehensive. It's not ever, nothing is ever going to fail. And depending on how bad the failure is, it could be, relatively trivial, or it could be a massive issue. And we've certainly had, like I mentioned, 6-figure outages before because the model was just broken, because the pipeline changed in some meaningful way and it couldn't process data anymore. And it's kind of hard to tell exactly which of those two is worse, because a pipeline failure just stops everything from working, right? Like, so any customers that come in and try to leverage this model don't have access to it. That's a really bad customer experience. It's sort of the equivalent of you go to a website and the website's down. Yeah. But the other failure, the business logic failure, is oftentimes even worse because it's a silent failure, right? Something changes, the pipeline continues to work, but the model has now lost its predictive capacity, and you wouldn't know that unless you really understood how the data had changed. So both of them are quite bad.
I'm already getting hot from the stories. Like, I can imagine when the freight costs are the estimated freight costs are cut in half because somebody changed miles to kilometers, leading to negative margin, or your application being down, right, because of the null values in the pipeline. That must have been very stressful. And you're right. Like, this reminds a bit of what Nassim Taleb about his literature. These are fat-tailed distributions. It's impossible to build test cases for issues like that because they are so rare, and when they happen, they're really breaking changes. I guess when these things happened, that's probably when you start thinking, like, I need a solution, right? If there are null values in my pipeline, or there are breaking schema changes, this cannot lead to them calling infrastructure engineers in the middle of the night. Is this around the time that you came up with the data contracts?
Definitely, don't want to take credit for inventing the concept of data contracts. It's actually a very old concept. Martin Fowler was writing about the consumer-driven contract, a way back in 2008. And there have been many teams who have implemented some form of a contract internally. For example, Google is pretty famous for having internal data contracts where if you're a data team and you need to access some customer data for, maybe a model you're building or some other use case, you actually have to take out a contract with the data source owner that says, hey, we agreed to use this data in a very particular way and not outside of that. And there's other teams that have built out whole platforms around data contracts, like Zillow. So I won't say that this is an incredibly, widely understood, and it hasn't been institutionalized, but a lot of the larger companies already have systems like this, and they've actually had them for quite a long time. The thing that, if I can sort of stamp my name in the annals of history, I suppose, the thing that I did that was a little bit different was in the way I thought about applying the data contract. The biggest challenge, and I'm sure we can get into all of this, but one of the biggest challenges today is, well, I can maybe get a producer to sign an agreement or acknowledge that they need to ensure that data coming from a source system is high quality, but how do you actually materially do that through code? In the olden days, the days of pre-cloud data warehouses, you would have database constraints. And those database constraints, you would basically manage them in a centralized place, and you would ensure that there were validation rules in effect, things like, no null values. Every row in a column has to be unique, things like that. But the problem is, in the modern cloud, that's not how we do things anymore, right? We've sort of moved away from centralization, and we've really adopted decentralization as the de facto operating model. We have microservices for software engineers. We have the data lake. We have things like data mesh. And so nowadays, what engineers are doing is they're sort of pushing all of their data, or what data engineers are doing, I should say, is that we're pulling data from many different data sources into a data lake, and then from there, that data lake is sort of the artifacts in that data lake are composed into useful entities that can be made accessible to the rest of the organization. So there really is no one around sort of going into each database and managing the constraints anymore. Like, that role doesn't really exist. And even if that person did exist, they would probably get a lot of pushback from the software engineering team, because setting a bunch of constraints in a centralized way without context is not agile. It's the opposite of agile. And that doesn't really fly in the modern software engineering organization. So you need to be able to still manage the constraints and manage the upstream ownership in a way that maps to how modern tech teams actually operate.
You need, again, to introduce some data modeling, because that's probably also correlated with the DBA kind of becoming less and less popular, and the growing popularity of the data engineer is the fact that you don't have that control anymore over the constraints, null values, and so forth. And that's something that you're bringing up now, right? Big voice for getting, again, those constraints in the data warehouses, in the modern data stack. And what role do data contracts play in that?
Let's maybe take a step back a little bit and just talk a bit about, like, what actually is a data contract? What are its core components? So the simplest explanation is data contracts are APIs for data. In the same way, a microservice owner has to think about what is the structure of the API, what is the actual content of the API, what is the semantic meaning behind it. They have to maintain the documentation. They have to maintain different versions of the API. They have to practice good change management. They ideally should know who the consumers of that API are, especially if they're internal to the company, and communicate if that API is changing in a backwards incompatible way. All of that entire workflow also needs to apply to data as well. But there are some differences. There's some differences in how we think about data and how we think about software. So in software, we have really adopted the siloed, iterative, microservice-based approach. And that means that every team is sort of decoupled from one another, and they're totally federated, and they're free to make any decision that they want within their microservice, as long as they're not impacting someone else. In data, it's not really like that. Like, data is, by definition, a tightly coupled system. Every data product, so to speak, a training set for machine learning model, a dashboard for, that the CEO looks at, all of these things are completely dependent on the data sources. They are 100% dependent. Mm-hmm. And as a result, any change that's made to a source is going to have some negative impact on whoever is downstream consuming this data. It's very different from a microservice. And so the traditional way that we think about APIs can't apply. The other really big difference is that generally microservices are built and APIs are built fit for purpose, meaning that when you're constructing the API, it already has a customer, it already has a use case. You're designing it to do something. And so all of the data that you generate sort of as a byproduct of that service it has some operational value. But in the data world, it's not exactly the same, right? Like data, figuring out what the use cases even are it requires a sense of exploration. We have to go and access the data that's being generated from these microservices that has a fit for purpose, that is fit for purpose, and then figure out how we can use it effectively. What are the models that we could build? What are the dashboards that we could create, and so on and so forth. And so that means that any data product we build is it's kind of after the fact, right? It's not built fit for purpose. It's built after the fact. And that means that there's sort of a fundamental disconnect between the producer who's managing this fit for purpose system and the consumer who's managing this sort of after the fact system. And so we can't have an expectation that the producer is going to be able to accurately take ownership of these contracts all by themselves, because they don't know what the use cases are that are leveraging the contracts, right? So as an example, if I am using data, or if I would like to use data to build a training set for a model that serves in real time, and I want to retrain that model every hour or every couple hours, then I will need the data to refresh in a much lower time interval. But if I'm using that data to build a report that the CEO looks at once a month, then my SLA is going to be much higher than that. And there's no way that the producer can know what those SLAs are going to be in advance, because the use cases haven't been created yet. And it's the same with any other constraint. If I as a data scientist need there to be, no more than 2% of null values in my training set, or else my model will start to get wildly non-predictive, the data producer doesn't know that, right? That constraint has never been given to them. And so the purpose of the contract is to have a single artifact. That's this mechanism of communication, which the consumer can say, here's the data that I actually need, right? Here's the schema that I need to be consistent. Here's the constraints that I need to have, and here are the SLAs that need to exist from my perspective, from the perspective of the data product owner. And that gives the data producer insight into, okay, well, this is how the data that I'm generating is now being used, and they can choose the level of enforcement that they apply to the contract that's been requested.
In a way, it's like you bring clarity in downstream consumption dependencies of the data created by a producer. And with that clarity, then you can create an agreement between the producer and the consumer based on the requirements of the freshness, the schema and support for the consumer, and even the purpose of usage. And like, as a privacy geek, for me, that's like a dream, right? Like, because you basically have purpose-based APIs for a certain purpose, and then that's communicated downstream. In an ideal world, that would also eventually venture down to the consumers that give away their personal data, and that they are aware of how their data is being used. But that's a completely different discussion. That's fascinating. So it's basically an agreement between a producer and a consumer. Can you also have chains of data contracts? Because like, if you look at data mesh, there you have data products can be based on other data products. Does it mean you'll also have chains of data contracts?
This would be a requirement, at least at some point. In the majority of cases, data, a lot of these use cases, are derived after multiple transformations and sort of eventually manifest in some warehouse. And Snowflake or Databricks could be used as that warehouse. But it could be, the data could be handed off 4 or 5 times. Like maybe it starts in a Postgres database, and then from there the data flows to a Kafka topic, and then from there it flows into a data lake, and then from there the data might be, if it's following the medallion model, you sort of have your raw layer, and then you have your, sort of silver more like lightly aggregated layer, and then you have your gold layer, which is your data marts. And then, you know, from your data marts, the data might flow to some specific to the actual training set, and that might be multiple aggregations. So you could have, you know, 5, 6, 10, 15, 20 upstream data owners, like, very easily. And so if you want an asset, a data product, to be protected, it means that you need a level of contract coverage, right? You need to have contracts everywhere that a upstream producer exists, and that contract needs to be enforced throughout the whole pipeline. Now, my perspective, and this is where I differ from some other people in the space, is that you don't need, nor do you want, contracts everywhere, because it becomes a burden, right? In the same way, like, there's a lot of data in the data warehouse that is not particularly useful. There's a huge amount of data in the data lake that's not particularly useful, right? It's just sort of exhaust, and we may or may not find a use case for it later. And we don't want to slow down the engineering velocity who are managing these data sources just because some data exists, right? So, for instance, you know, imagine that there's maybe a pipeline that was built a couple of years ago by some analyst, and they're not at the company anymore, and they you know, created a view for a product manager so they could analyze churn of some product that doesn't even exist anymore, right? The data is still being pulled in, but like the product or that particular feature is like not really one the business decided to continue optimizing. Well, you wouldn't want a contract on that data, because what that's going to do is it's going to require every producer in that pipeline to treat any change made to that data set as if it was an API. It will be version controlled. There'll be some sort of schema management. They'll have to make sure there's backwards incompatibility. If the data is not useful, then you don't want to layer on all of these governance controls. You only want to do that for data that is being treated like a product, where you need the data quality, and that's actually a much smaller percentage of the data assets in a data warehouse, right? It could be the training set for a machine learning model. It could be the tables that are used in an accounting pipeline. It could be if we have a table that we're pushing out to a customer and we're embedding some metrics in a website or in an app, we definitely would want that under contract. So there should be a much the amount of data under contract is a subset of all the data that you have, and therefore the amount of contracts that you need per pipeline. You essentially need to think deep and not wide.
You can have chains of data contracts for important pipelines, but you don't need data contracts for everything. You only need data contracts for your important data products that you want to treat as, for your important data sets that you want to treat as data products, where you have versioning and you want to prevent those breaking changes. Now, the data contracts, the way you describe it now, makes a lot of sense for a consumer, right? I have my report for my customer, or I have my ML model where I don't want to have null values and so forth. It makes sense from my perspective to get a data contract. What's the incentive for a data producer to engage in such a data contract?
There's a lot of incentive. The big incentive is you don't want to break things. You don't want to break valuable things that are useful to the company. The problem is today they don't understand, the producer does not understand that problem is even happening. And so if the problem becomes apparent and it becomes visible, then there is a natural reason for the producer to want to solve that problem. So for instance, if a data producer was making a change to an upstream source and they were told in their developer workflow, hey, this change that you're making is about to break a dashboard the CEO looks at every single day. And when you make this change, we're going to know it was you, right? Because we're going to know the PR that actually violated the contract. That completely flips the incentive, right? No engineer wants to be in a position where they're blamed for breaking something that's very useful to the company. It's just today, they don't even know that that's happening. So there's no way they have the ability they can't take the accountability in the first place.
So producers, they want to create reliable data. They want to help the organization. They want to help the CEO. They want to help with their products. They just need visibility in it, right? It's not that they want additional accountability. They feel accountable. They just want to have that visibility. And you mentioned that, like, you mentioned something like, hey, this change can break the report for the CEO. Does a data contract, does it prevent breaking changes, or does it monitor breaking changes? What should it be?
It really depends on what data is most important. What I always recommend starting with in the contract is the schema. And that's because the schema is one of the easiest things to enforce. It's the easiest breaking change to detect in CI/CD, which gives you that ability to let someone know upstream that they're about to do something that is bad. So there absolutely is a preventative component to the contract, meaning that the contract itself, there's different components to there's different technical components to the contract. The first major technical component is the spec, and that's essentially just the description of like what the data is and what are its constraints and the SLAs and so on and so forth. But the other component of the contract is the mechanism of validation and enforcement. And depending on the type of constraint that exists, you will have a different mechanism of validation and enforcement. If for schema, then it is a preventative mechanism, right? That's a check during CI/CD. If it's not schema, then the goal should be to try to catch the issue as early as you can in the pipeline and then provide that feedback as quick as possible to the producer, because you don't want them to wait hours or days or weeks until they learn that something has gone wrong. So yeah, it's a combination of both, and the goal really is sort of this a very similar paradigm as Datadog. Datadog and GitHub, I would say. The way that software developers use these tools is to they want to be stopped in CI if there's something that breaks, if there's something that's going wrong. There's a human in the loop that can actually tell them, hey, this change that you're making isn't going to work for X, Y, and Z reasons. I'm looking at your code. There's something wonky going on here, and you should fix it. And then the way that they generally use Datadog is I'm publishing changes to production, and I want to check the error rate. I want to check the quality of responses I'm getting from the application. Like, I want to ensure that everything looks right, directly after my deployment. And this is sort of the function that the data contract serves.
Sometimes the data contract can prevent breaking changes, like changing a schema or changing a column from miles to kilometers, or sometimes it just helps with the monitoring. For instance, when there's null values in a pipeline, it will just help you find those issues more quickly, so that you can respond in a timely fashion. It seems that there's a lot of metadata and sorry about that. Worked at Calibra for 4 years, so it's something is always stuck with me. You describe that there's a schema in there, description of the schema. Do you also have like semantic meaning of the data in the contract?
I think that there should be semantic meaning of the data in the contract. There's various ways that this can be enforced. If you treat any data asset as if it is an API, then an API has semantic meaning as well. And you can certainly inform a data producer that if their API appears to be changing in some meaningful way, you can ask them if it still corresponds to the semantic meaning that has been laid out in the contract. Like, hey, I see that your API is changing. A single row in this data set is meant to represent X. Does it still represent X? This column called shipment distance in miles was always meant to be expressed in miles. Like, does it still mean that? And you could have a workflow where, in order to publish a change to the API, the data producer has to sign off and sort of like acknowledge that all of those requirements are still valid. And if they're not, then they need to communicate that to a consumer, that, hey, something has changed and you have a certain amount of time backfill, to prepare for a backfill, or to update your query accordingly.
So when you have semantic meaning in a data contract, it doesn't seem as something that is essential for data quality. It's something that you can have for discussions and interpretation. But if you have semantic meaning, could you also use it for, I don't know, discoverability? Because earlier we talked about having a lineage of data contracts, a sequence of data contracts. You can have semantic meaning in a data contract. It almost looks like the perfect data management solution, or like the perfect data governance solution. You get insights in what metadata you have, both technical and semantic meaning. Do you see a future there, that it's like some kind of integration with the catalogs maybe?
I think a catalog has a lot of useful information, and it definitely, I think contracts absolutely should be integrated into catalogs. Catalogs have a few operational weaknesses, in my opinion. Mm-hmm. The first, at least the downstream, I think the very downstream catalogs. But if they are incorporated with some type of contract, then a lot of those operational weaknesses kind of go away. Right? Like, one thing I've heard from catalogs and catalog owners is that, like, it's really hard to motivate someone to fill out the metadata of a catalog. And that's just because, I mean, and I did this, right? Like, I had to go around and ask people to fill out all of their information. And it's because there's not really a great incentive for them to do that. And I think what a lot of folks think about in the catalog is like, well, it's basically a form of documentation, and engineers do documentation all the time, so why wouldn't data people? But data people come from a very different background. They have a very different workflow. They're much more isolated than an engineering team, right? A team is sort of thinking about how all these services work together. There's a lot of reliance on other people's services, whereas a data professional doesn't really see themselves in that way. They see themselves as, hey, I'm sort of generating a POC, a use case. I don't actually want anybody to take a dependency on me. I'm going to be totally isolated and by myself. And so it makes sense, like, if they understand the data, why would they need to go in and document it, thoroughly for the rest of the company? But if you have a contract-oriented sort of workflow, then it totally changes things, right? Because the documentation and adding the metadata is actually a vehicle of communicating with the producer and telling them the things that you need, right? So you can say, hey, like, I always need these constraints to look like X, Y, and Z, because if I don't get it that way, then my data product is not going to work how I expect. And so if you don't have a contract, or to put it another way, if you don't fill out all that metadata, then you have no expectation of quality, right? And maybe that's okay. Maybe for the experimentation POC phase, you don't need that quality because it makes you go slower. But once you've actually defined something that needs to be production grade, well, now I need to go back and sort of add all this stuff. So yeah, I think the contract is actually a huge benefit to a catalog, because it incentivizes filling out all of that metadata, and you have a great surface for sort of activating the metadata, so to speak.
Super insightful. So, I mean, that is key, right? Motivating people to fill out a catalog, enter the metadata, the semantic meaning. It's always after the fact. They don't want to do it. But what you're basically doing is, because you motivate them for good data quality, you kind of motivate them to shift data governance left, right, as you're creating data products. That's when you describe them in a data contract, because when you do so, you're going to get dependable data. And as such, by doing that motion, you also fill or complete the data catalog. So it's kind of two birds, one stone, because the ultimate incentive is data quality, right? It's the ultimate driver.
Exactly. Data quality, latency, all of those things. If you tie the things that the data consumer wants to the metadata, then of course they'll add it. To your point. So yeah, I think this is why I'm sort of very bullish on the contract, because I feel it is one of the missing components in the communication workflow between the data producer and data consumer, right? This is also one of the issues with downstream monitoring tools, which again are great. I think that they're solving a big problem, but One issue is if you build out this whole sort of monitoring and anomaly detection system and it runs on top of all your data and you start getting all these issues, okay, that's very informative, but now what, right? Like either 90% of these problems are coming from source systems. And so if something is coming from somewhere within sort of your Snowflake environment, great, you can go and resolve that. But if it falls into that other 9 out of 10 times where it's coming from a source, what are you going to do? It's like, well, you just now have the information that something failed. And what a lot of data engineering teams and data infrastructure teams are finding is having the monitoring system can in some cases make their life worse, not better, because you have all these sort of little fires, these little failures that were happening in the background, but nobody was really detecting them. And now all of a sudden you have visibility into it. And the expectation is if something is failing, then it's going to get fixed. And all of that is going to get put on the central data engineering team, and they don't have the capacity to fix it because, like we've talking about, they don't control the source systems. So, my feeling is every single, and the next thing that happens after that, which is quite unfortunate, is that if you have a lot of alerts, a lot of monitors going off, and none of those alerts are being resolved, then it leads to alert fatigue.
Fatigue alerts, yeah.
Right, where now the monitors don't start to mean anything because you know that there's no action that's going to be taken. So it just becomes noise in the background, and these products that are doing something very useful suddenly become useless, right? They just get ignored. And once the monitoring tool gets ignored, it dies, right? There's no reason for it anymore. So I think that one of the most important things for any data engineering and sort of data quality team that cares about data quality to think about is how valuable is each individual alert to the person who needs to consume it in order to solve the problem? And if the answer is not very valuable, or they don't even receive it in the first place, then you should probably think about doing something different.
It's a bit about like the boy who cried wolf, right? If there's an alarm going off all the time, but people don't have the tools to act on it, people are going to start ignoring the alarms, or in the case, the boy that cried wolf. Fascinating. One thing that you said was, I'm still thinking about it right now, is that software engineers, they work in teams, right? They work with APIs, it's all connected. Data workers, they work alone. How do you see that with data mesh? Because I thought now with the data mesh framework, it's all about, having the main teams where the data, the data engineer works with the analyst, has a product manager. They talk with other teams through data products.
Yep.
How do you see the data contract play a role there?
Seeing some of the data mesh implementations in practice, I feel that data mesh is a lot like Agile, right? They both came from ThoughtWorks. They're both operational, sort of like organizational paradigms. It's not really technology. Yeah. And if you go into a waterfall oriented engineering organization and you say, okay, it's time to do Agile and it's time to have great documentation and it's time to be iterative, most of the engineers are going to look at you like you're crazy, because like how do they do that, right? I think that's sort of the big question. You can reorganize your entire business to now be Agile, and you can hire 500 people and you can restructure everyone into teams and all this other stuff. But I think that there was a lot of resistance to that. Where Agile started to become quite popular is when the underlying system, like when the incentives of the actual IC started to line up with the organizational model. And that was through the tools, honestly, GitHub and version control and APIs and CI/CD, right? Like and each one of those things added value to the life of the engineer. It made their life better. Like, oh, I can deploy my code. I can do iterative review. I don't have to do these sort of big, weekly or monthly code reviews with my team. I can do it sort of one block of code at a time. If something fails, it's detected by the system and they can roll it back without me even worrying about it. If it fails and the system doesn't detect it, I have other systems for detecting those issues, and I can roll those back very easily, right? So it just makes their life a lot better. And then you can say, okay, well, now that I've sort of got this, all of these people who are kind of using version control and using, all these other systems, now I can add Agile on top of that, and it just kind of brings organization to each person's own individual implementation of that system. I think that data mesh is going to follow a very similar paradigm, where if you go into a company today and you say, hey, you need to reorient your entire business model around data domains, and you need to stop working on shipping products so fast, and engineers now need to be accountable for data, even though nobody's really telling them why, and they need to take ownership over data products, even though they weren't doing it before. Like, that is going to be met with an enormous amount of resistance. And in pretty much every company, I haven't actually seen an implementation of data mesh. I've seen, in some cases, a team might do it. Maybe a couple teams might do it. There's usually some desire for companies to want to do it, but it's really, really hard operationally to shift companies to this like new paradigm. What would make it a whole lot easier, in my opinion, is if you had all of the systems, like you had contracts, which are the APIs. You have some version of you have a catalog, and these things are like tied together, and the data people are actually motivated to like use the catalog, aka they're motivated to do documentation. That you have like that you're using events, right, which sort of maps to the verbs of some domain. You've got the entity, you've got the event, right? When you have all the underlying systems, then it starts to become a lot easier to go in and say, hey, software engineer, you guys already own 3 or 4 data contracts, right? You're already maintaining this stuff because you know that it's useful to the downstream team that's consuming it. You're already managing these constraints. You're already doing this documentation. Why don't we just add domain level ownership to your scope of work? That becomes a much easier conversation to have, in my opinion. So that, I think that's what the relationship is.
It reminds me a bit of Conway law. Well, basically, what you want to have is you want to have an organization where you can have these dependencies, right? And that requires different way of communication. Because throughout our chat, communication has been like a recurring theme, right? You started off by saying a data contract allows a data consumer to communicate with a data producer to communicate their dependencies. But what is kind of missing is the technology to support that communication, to support the communication that you need in the data mesh, right? It's a different way of communicating. And now what technology allows is to introduce that communication that you need for data mesh. Hence the organization follows the lines of communication. Hence you can have a data mesh. So in a way, data mesh, although it's more of a framework, it requires the tools to drive the Conway law, and that your organization can implement a data mesh.
Exactly. And I think the underlying sort of assumptions is that, the data mesh is the right thing to do. It's the right thing to do for the business, and it will yield better outcomes for the business. And therefore, if it's the right thing to do, and it's the best thing to do, and it makes everybody's lives better, then people should naturally gravitate towards it if they are given the capabilities to accomplish all these things. And if the answer is no, they don't, right? If they have all the systems to accomplish a data mesh and they don't drift towards data mesh, then it means maybe data mesh is not right for that organization. And that's totally fine also.
Yep. Or leadership is missing the vision, right? So we mentioned APIs, we mentioned data mesh, right? These are 2 things where access management plays an important role, right? So data mesh talks about federated computational governance. You let data teams define, or data owners define access controls. If you talk about APIs, right, data contracts are API-like agreements or contracts for data. Well, if you talk about an API, maybe stretching the analogy here, but when you look at an API, access is managed through tokens, right? And in a way that can be completely federated. How do you look at access management in their contracts? Because I was talking to Jean-Georges Perrin from PayPal about their data contract template a while back, and they describe the roles that you need to assume to access data. So it's more descriptive. It's not really for enforcement. So one, do you see a role for access management in data contracts? And if so, should data contracts enforce access management or should just be there to inform?
I do think that contracts should enforce access management, and I think it's totally possible as well. Because they have a tight coupling with the data itself, right? The contract is a spec, it's stored in Git, but fundamentally it should be mapped to some pipeline. Each constraint should be mapped to the node in the lineage graph where the constraint needs to be enforced. Then there's no reason why you can't manage access control from within a contract, right? In fact, I think that this is a necessity. What you and I have been talking about is sort of one side of the contract, which is the expectation of the consumer from the producer, right? As a consumer, I have certain constraints. I have a data asset that I'm using in a particular way, and I need the producer to give me what I need. But a contract is bidirectional, right? And it goes the other way, right? If I'm a producer, then I would expect my data to be leveraged in the way that a consumer says they will. And I think that that's very multifaceted. So I do think that the access control and the access management is a big part of that. I think that PII is a big part of that. I think even that like usage, right? Like if you said, if a consumer said, "Hey, I'm going to be, I need this contract because I've got my machine learning model and blah blah blah, and it's going to be all great and it's amazing," and then 6 months pass and that person says, "Well, I don't think we're going to use this model. We're going to go in a different direction." Like I mentioned before, that producer probably shouldn't be required to maintain that contract anymore. And because of the cost to them. And so there has to be this bidirectional communication where all of the components, all the expectations of the consumer are also being monitored for as well. Yeah. And I think that's all like totally doable.
Wow, the privacy geek in me is becoming very excited. Maybe finally we'll have purpose-based access controls. And like for cost management makes sense, right? I'm asking you to maintain a pipeline for my ML model that I never built, right? You're going to keep me accountable for that. One thing that fascinates me is, okay, so with a data contract, you now you align the purpose of a data product, right? You can only use data for a certain purpose, which is great for purpose-based access controls. And the domains have that knowledge, which is good. Now, one thing I always wonder about that is, right, what about PII? What about privacy regulations? Because when you work with data, now and more increasingly, also in the States, all the states have their own individual privacy regulations. You got to comply with security regulations, security standards. It becomes very, very messy quickly, right? And you can't expect data producers and data consumers to have that knowledge of all these regulations and the interplay and which is more important than the other one. So that immediately brings me to the question. There's probably a data governance team or InfoSec that has that knowledge on how to protect PII. But if you federate access controls completely to the teams setting up the data contracts, is there a way that your central data governance team can still keep control over your PII? You got to comply with HIPAA, you got to comply with CCPA. Oregon has a privacy regulation now, GDPR. There's a whole bunch of security regulations on the horizon. Like, how can you keep that central control with data contracts if they're used to enforce access?
The interesting thing is that not every team is going to need the same level of governance at the same time. And so what's important is that the data teams can layer on governance incrementally as and when they need it. And in order to do that, you need to have some central artifact that evolves and changes as the business evolves. So what we've been talking about primarily in this conversation is a world where today is the Wild West, right? There is no governance, there is no control, there's basically zero upstream data quality. And in that world, the most important thing to do is to drive the communication between the producers and the consumers, drive the ownership, drive the management, the initial management of the data and those APIs. However, once that's in place and the business continues to grow, and a lot of these regulations now are looming in the distance, you know, the GDPRs, CCRAs, everything else. Well, now actually comes the time where you can begin to layer additional constraints into the contract from the perspective of the business. So before it was from the perspective of the data consumer, but the contract it's just metadata, right? And so you can layer on business constraints as well, right? Like, hey, we have a certain set of regulations that we need to follow. We need to make sure like this pipeline is used for accounting. We get audited on it every single year. And there's certain standards that we need to follow. Like if anything in the pipeline is changed, then we need to go through some process, and you have to validate that process has been followed before you get to deploy that change, right? All of these things can be layered on top of the contract very easily. It's one reason that I recommend to use YAML, because it's so flexible. So any configuration that you put on top of it can very easily interface and essentially produce, you know, some monitoring system out the other side, some CI/CD check out the other side, whatever the technical vehicle is of sort of enforcing that change. So yeah, my view is that there's sort of maybe like a 3-stage maturity curve to contracts. The first stage is just pure awareness. We want producers to understand what their dependencies are from a use case oriented perspective. And we want consumers to be very active in adding like metadata and documentation that gives the producer that context. The second phase is the true ownership of an API, right? So it's sort of the upstream inputs. It's being able to take requests to that API over time. It's owning a single contract that services multiple use cases. So you don't want to have, 10 different use cases and 10 different contracts on the same data source. And that should ideally be like pretty decoupled from whatever the underlying data source actually is. So someone might say, hey, I want to be able to change my database however I want, as long as I'm still meeting the constraints of the contract, it should be fine. And then the final stage to me is the governance and the compliance and sort of business level constraints for like regulatory purposes.
Fantastic summary. So data contract, it's a 3-step approach. 1 is just to observe, to understand. 2 is to govern the relationship between the producer and the consumer in a technology agnostic way, right? And then 3 is to broaden the governance to the whole organization and make sure that you remain compliant with privacy and security regulations. I think that's, I think probably now there's a lot of CDOs whipping out their credit cards saying, I need to buy this, I need to buy this. It looks like the silver bullet for data governance, what we've been looking for the past 20 years. Chad, really appreciate the super insightful discussion. I learned a lot today, so thank you so much.
You're very welcome, and thank you for having me on.
Awesome. And for the people listening at home or at work, thank you so much for logging in. See ya. Bye-bye.